Hi everyone. We have a TP-Link router here. This is quite an old one, but it's a quite famous one in relation with OpenWrt because it's very cheap and you can run OpenWrt on it. Only pain in the ass is, I think, the previous model or also the current model has only 5 megabytes flash. Not much. But today we will have a closer look onto this device. It's actually the TL-WR841ND. It's a router which has a WAN interface, some LAN interface. It has Wi-Fi 4, supports up to Wi-Fi 4. Yeah, and it's quite cheap. I think it's in Germany it's for 16 euros on Amazon. So quite a nice piece of hardware to play with. Okay, let's first remove the antennas. Okay, then let's Okay, here we can actually see the actual router board. It's not very much on it. Yeah, let's start. We have power input, power button. We have a reset button and or a Wi-Fi protected setup for Wi-Fi. What is the thing for? Let's be quickly show. Okay, Wi-Fi on off. We have this switch here. Then we have Ethernet and its transformers. Here we have the TECHWOLF chip, which is actually the microprocessor here on the board. And we have a flash here. Okay, let's have a closer look to the hardware. Let's first check on the internet. So as you can see here, we have our router. This is the WR841N. The D stands for detachable antenna. In this case, we have that model. You can see we have only 4 megabyte flash, 32 megabyte RAM, some buttons and so on. And our router is the version 8.1, so it has this microprocessor with good 500 megahertz, 5 megabyte flash, and so on. And we can have a quick look on the datasheet of the microprocessor platform, which already shows, hey, this is a MIPS processor, so it supports the MIPS architecture. And this datasheet may be required later to find the UART interface on the board, but everyone who's not blind probably already saw it. But we will keep this open for in case we need it. Okay, back to the board. Let's check what we can see here. Yeah, we have the power input and the power button. And then we have here also a reset button and actually it's a power switch. Sorry, here we have a Wi-Fi on off switch. Here we have the LAN and WAN ports with its transformers. Here it's now getting interesting. This is the microprocessor, which is from Atheros, as we just saw on the web. This is actually the RAM. This is the 128 megabytes RAM. And here we have the flash. It's a very tiny chip, but here's the flash, 4 megabytes. We can see here, this is probably the UART. which we will test out. Here is also some interface. Not sure what this is. Could be a debug interface. Yeah, we have some inductors, capacitors, and so on. And on the back side, there is not much. Only some resistors and some capacitors, so nothing to worry about. Okay, then let's have a closer look on the hardware. So in one of the next steps we will connect the UART interface, but we don't know which port is which is ground, which is receive, but I think you may not can see it here, but I think this is the ground and this is transmit, receive, and we will quickly check this with the power meter, with the multimeter. Okay, this seems to be ground. This seems to be power. And this seems to be send and receive. Okay. Which one is which we will find out later. Alright, good. I prepared all the parts to solder the UART connection. And this is what we are going to do now. Alright, good. Let's have a quick look. Also I prepared the serial line. The UART pins are soldered, but let's have a quick look. So just googled for the supply, but it is a 3.3 volts, the UART. So just in order to take the correct converter. Let me get a USB extension. So what is what? Blue is ground, and ground seems to be this here. I don't know which is the receive path and which is the send path, but doesn't matter. We will just check it. We have the power here. Just have to make sure to not producing any short. Okay, I connected the UART cable. We have the, I'll just use Minicom with a baud rate of 115,200. Let's check if it works. Okay. So it is actually booting up, that's very good. I will just zoom a little bit out. Okay, let's check. Do we have a lock-in? So route is not working. Route and route reverse is also not working. Okay, so good. Then what we can do is let's check if we can get into the bootloader. There's U-boot installed. Auto booting, okay. Okay, so there's no way to stop bootloader from booting, I think. Just boots up. Okay. So I'm just gonna save this in an extra file to have the capability to check what's going on. So if we scroll down here we see actually the MTD partitions. And we have one for U-boot, which doesn't let us in for pressing a button. We have one where it's only the kernel, one with the rootfs, one with the config. This is probably overlayfs, and one is R. That means they are probably calibration data for Wi-Fi and so on. And we have now, what we want to do is actually we want to get onto the system. There are several possibilities. We can, of course, install an update, which overrides the U-boot. Of course, we could install an OpenVRT, then OpenWRT, then we know the password and so on. But what we want to do, we want to, in the best case, find out the password and the root name, which is set here, and get into the system to see what's going on. One possibility would be to unsolder the flash memory here and just read it out. I'm pretty sure it's not encrypted. We would actually see it here. But this would be too easy. Maybe we try first if we can somehow do it without changing the target. That would be very nice. Maybe we can quickly go through the log. So U-boot starts here. So it's initializing some of the peripherals, RAM and whatever. Then it does the auto booting. I know that there's an environment variable where you can set the delay, but maybe we can Google here for auto booting. I'll just take some notes to see if maybe a special key can be assigned that you can abort the booting process and so on. So it's booting image. Okay, then it's starting the kernel. Flash passed from bootloader, RAM size, alright. CPU revision is okay. We have a MIPS as we saw before. We have, I think this is the CPU frequency. This is the memory frequency in this case. Then we have physical RAM. Then what do we have? Zone list, kernel command line. So this can be quite interesting. We have the console. We have the rootfs type. All right. PID. Let me quickly check something. PID hash tables. Writing error control, memory. IQs, mount cache, USB core. So there's even USB. SquashFS, as we saw before, that's probably a SquashFS. Then we have services like PPP. Okay. Okay, there's even VLAN support, 802.1q. Okay, then BusyBox is started. Okay, it wants to some models, but maybe they're not required. Okay, then we have the Atheros GMAC. So this could be related to Wi-Fi or Ethernet. Okay, it's setting up some stuff here, setting phi. Alright, setting drop CRC errors, pause frames. Alright. Okay. Okay, here's the Wi-Fi stuff, it creates the AP. And then I think it's repeating again. It's repeating and repeating. And now we have the login. So we have our target here. We saw that we cannot access it via, let's say, credentials which can be guessed. And next step is we will have a look on the NOR flash, and for this we will use this tool here. This is actually a flash programmer. It uses SPI or I2C, and here is the in-circuit probe, so that we don't need to unsolder it. We will try this first, and then let's see what's on the flash. So for this we turn off the target. We remove the power, and here is our flash, and here is the probe, and this dot indicates there is the one, and here the red wire indicates this is the one, and we just need to put it on there. Okay, this looks good. We disconnect the UART. Okay. So as we saw on the datasheet before, this is a 3.3 volts GPIO. So we just have to make sure our SPI is also on 3 volts. Yes, and it is. Okay, then let's go to this window. This is actually the programmer. I will connect this now to power. We see the target is powered, so could be that this doesn't work. So it says connected, let's say detect. Okay, there's no chip, so we can also not read back. Yeah. Okay, what the problem is actually, as you have seen, the LEDs went on, so the whole board target is powered by this programmer, which shouldn't be the way. So to do this in chip will not gonna work, and we need to unsolder the flash and see what's going on. Okay, I got my soldering equipment out, so let's unsolder here the flash. Can we somehow see what flash it is? I mean, we saw the datasheet, but here you can see. I think we have we have it open, so then let's start unsoldering the thing. Okay, so here we have our unsoldered chip, the flash, no flash. Here we have our in-circuit programming cable, which we cannot use, and we will instead use something like this. This you can insert the chip, which can be connected to here, and then you can read or write to it. Okay, then let's put the chip in here. Okay, here we have the little flash. Here we have the cap tool. What we are doing now is we will place it here. We quickly zoom in. Okay. So let's take the chip. Okay, you can see we have placed it, but we have to go down with these clamps. I'm not 100% satisfied. Now it looks good. We see there's contact here and here. We have to remember that here is pin 1. Good, but this looks good. Then let's try to read it out. Okay, we have our flash mounted here. We will remove the in-circuit programmer. We have already made sure that this is 3.3 volts. And we will connect. This was the first pin. This is pin 1. We will connect it this way to this programmer here and then close it. And this hardware is ready set up. Okay, then let's connect and try. So we connect this here and then let's have a look. So this is actually the programmer. So let's have a look. It's connected. Let's try to detect, and that's correct. SPI Spangen S25FL032P 4 megabytes. So this is correct. And I would just say let's start reading out. So it's now going to read the whole flash, and we will later see how we can extract the data from this. Okay, we will save this. So let me quickly save it in the background. You can't see it. Okay, we'll just read it a second time, just for safety reasons. Save it again. This is backup 2. Okay, and as you can see here, this is actually a raw dump, so the whole flash content is just dumped as it is. And these are actually things like the bootloader, U-boot, Linux, rootfs. So